I want to test this DC to DC converter LM2596, which is a buck converter step down to its capabilities of 3 amps, how it's heating up, what's the voltage drop, and in the end I will test the most popular on MakerWorld, the cases for it, or they will melt or no. So let's go. Hello world and welcome. I've been using this DC to DC buck converter for many years. I ordered it in a bulk a long time ago. I've been using it for my microcontroller projects which require 5 volts or 3.3 volts, or even something beefier like this one. The advertisement for this is maximum 3 amps on the output side. I want to see how it will go on a thermal camera, and if there is a voltage drop if we go above some sort of amperage. So I'm going to start slow with 1 amp, then will go to 2 amps, and then to 3 amps, and later on I will put it in a PLA and PETG cases and see how they will perform. This is my setup. Here's the DC to DC converter hooked up to a lab power supply. I'm gonna control all the voltages with my multimeter. This is my load, and I will record everything from the thermal camera, which is just above it. Let's start the test. 1 amp test finished. So from 12 volt to 3.3, 12 volt to 5 volt, and 24 volt to 5 volt. All the tests are 30 minutes. The efficiency, yeah, it's bad, but you can work with it. The output voltage difference was minor, so that's great. What was interesting about the temperatures, that the switch itself, LM2596, was around 60 to 70 degrees on the 24 to 5 volts. The hottest item was the diode, which is 5534. Still fine under 80 degrees Celsius, but that's something I didn't expect. From now on, okay, let's go for 1.5 amp on the output and see what happens then. Like, this was a shocker. So on 1.5 amps on the 3 tests, the converter went to almost 90 degrees on 5 volt output from 12 volt input, and the maximum was 106, which is in the spec. So the spec says that maximum junction temperature is 150 degrees Celsius. So we're in the range of that, but it's only half of the power. But that's not the shocker. The shocker is the diode. The diode went to 114 degrees Celsius. So if we check the specification there, which is SS34, the operating junction temperature is to 125 degrees Celsius. 11 more degrees and we're in the maximum range. And we're pulling only 1.5 amps. So the diode is here, which is, the hottest item. I don't think we're gonna pull like more than, I don't know, like maybe 2 amps maximum. I will do a 2 amp test on all of these, and from there we will see what's gonna happen. The scariest part of all of it is with the cases. Like PLA, like come on. Like if you pull 1.5 amp, it's I think it's gonna melt. The same should be for PETG. I think I need to print a ABS version. But yeah, let's try 2 amps and see what happens there. Wow, you won't believe this. For the 12 volt through 3.3 volts, we went to 116 degrees Celsius, and on the diode 122, from 12 to 5 130, and on the diode 118 from 24 to 5 volts. On the converter 131, and on the diode 143. So we exceeded the maximum junction temperature. How you can pull 3 amps? How? I'm not saying that Texas Instruments are at fault, but that means these chips and this diode is fake. I'm not gonna go more than 2 amps. This was stressful already. I know the converter, yeah, it can take 150, and we're only at 131. But no, I don't have a safety gear if that shit blows up. No. Let me just show you like real fast. So 12 volt in, 5 volt out, and on 3 amps. And the diode is at 122. 138. Like no, and that was a minute. Like no. Like really no. Wow. Okay. Let's try to melt some filaments. So this is the most popular model on Maker World for LM2596. And yeah, let's add it and test. I will do only for 30 minutes 12 volt to 5 volt output, and see when it melts on 1 amp, 1.5 amps, or 2 amps. So PLA, PETG, and ABS. This is the current setup. So 12 volt in, 5 volt out. We're gonna start with 1 amp and PLA. I'm giving it the best case scenario that is not laying on some table, ground, or whatever, so there's a place for ventilation. So let's see when it starts to melt. Half an hour passed. Let's see. Now it's still good. The side. Good. And the bottom. Still good. Okay, let's increase it to 1.5 amps. After a half an hour, it should be soft. But it holds. No, here we go. Yeah. What's at the bottom? Yeah, it's soft. It haven't broke down, but yeah, it's soft. Ooh, Yeah, it's going in. But it still holds its form. I don't know, maybe for lows let's go for 2 amps, like with no reason, but why not? I thought it gonna collapse, but no. Interesting. So let's see. Oh yeah, yeah, it's soft. All of this. Yeah. Let's see the side. Where's the diode? The diode. Okay, 74. Yeah, flex. Yeah, we're good here. And at the bottom, oh no, there's a give. But not bad. I thought it will collapse, but it didn't. But it's, yeah, it's soft. It's holding it. Okay, so that means for PETG, it will definitely hold, but we'll see if it gets any soft, because PLA gets soft at around 60 degrees Celsius and PETG is around 80. Let's go for 2 amps and see what happens. So after half an hour, let's see how PETG stands up. Yeah, it's deforming. And how this side is 78 degrees. Yeah, it's soft. Damn. Oh, this is interesting. What's here? Ah, that's just the bottom. And for the bottom, oh yeah, it's soft here. Yeah, even PETG for 2 amps. Okay, let's try ABS and see how it's all gonna hold up. Half an hour in and see how ABS holding. Damn, it's good. A little bit of deformation. Yeah. Out the side. Okay, that's good. And the bottom. And the bottom, yeah, deforming. Starts to deform. It's soft. Not too soft, but for ABS, yeah, you can go with it. Conclusion time. For this converter, I wouldn't go more than 1.5 amps, because at 2 we were over the rated temperature on the diode. For the enclosure, PLA less than 1 amp, PETG max 1.5, and that would be the max that I would use it unmonitored. For short term, I don't know, like 5-10 minutes, you need it to, okay, go for 2 amps. Then you can use ABS. Yeah, it's good. 3 amps, definitely no. Like, definitely no. Better be safe than sorry. For all of this, I think next thing that I want to test is this XL6009E1. This is a boost converter. I'm mostly using it from 5 volt to whatever, 10, 12, 14. I want to see how this performs. So yeah, get subscribed, give me a like, and stay tuned. More upcoming.